So here we have a metal ball on a spike and a metal ring, and we can see that the ball actually fits through the metal ring. It's a fairly snug fit, but it fits through quite easily. What we're going to do now is heat the metal ball. Now, when we heat something, we're giving more energy to the particles. When the particles have more energy, they get to move around more. But if the particles are moving around more, they're taking up greater space, they're taking up greater volume. So it's a bit hard to see right now, but the metal ball is actually increasing its size. Not by very much. Not enough to be able to see just with our eyes. However, if we try and put it back through the metal ring, which we saw before, it did fairly easily. It was a fairly close fit, but it easily fit through. Now we can see it doesn't. We've heated up the metal ball. Particles got more energy, they moved more, they take up greater space. It now no longer fits through the ring. If, on the other hand, lack of water. Alright, we're back with some water. If we actually cool, hang on, there's the water, there it is. If we cool it down, if we remove the heat, we're doing the opposite. If we remove the heat by cooling something down, the particles have less energy, they're moving less, they're taking up less volume, less space, and once again, the ball will fit through the hoop. Now, as an extension to what we just did, the metal ball fitting through the ring, through the hoop, what if instead of heating the metal ball, we heat the ring? What will actually happen there? Because in heating the ring, we're giving, same as we did before, we're giving more energy to the particles of the ring. The particles, because they have more energy, more kinetic energy, they're moving more, they're taking up greater space. But what does that mean in terms of will the metal ball fit through or not? Because maybe the ring is getting larger all around, or maybe it's taking up more space in all the dimensions, in which case the hole through the middle, through the ring, would actually be getting smaller. If the metal on the inside of the ring is expanding, taking up more space, it would have to expand into this space. That would make this diameter smaller, so the metal ball won't fit through anymore. So there are a couple of options. That maybe the hole through the ring gets smaller because the metal is expanding into that space. Maybe the hole stays the same size and the rest of the metal expands outwards. Or maybe the entire ring gets larger, so the overall diameter is larger, but also the diameter of the ring, in which case the metal ball will fit through even easier. It won't be a snug fit. 3 options there. Let's see what we find. Well, the ball still fits through, so the metal didn't expand in all directions and therefore start to close off the hole. But it's still a very snug fit. The ball fits through, but there's no wiggle room. It's still a snug fit. What we actually find is that as the metal of the ring expands due to the heat, the particles get more energy, they move more, take up more space. It actually expands as if it were a solid metal disc. So it's expanding outwards. The hole of the ring actually stays the same size. The metal expands outwards from there. So the hole actually didn't get bigger. The metal expands outwards as if it were a completely metal disc, and this was all solid in here.